Last time we had started section 3.3, and we'd gotten mostly finished with it. We were looking at increasing and decreasing functions, in particular to be able to help us to determine maximum and minimum points on functions. That's what we were doing it with. We had gotten to the point where we had started this one example about graphing, and we had found asymptotes, vertical asymptotes, horizontal asymptotes. We had found the derivative. Do you remember why we were finding the derivative? What's the purpose in that? To find critical points. What are critical points going to tell us, potentially? Maximum minimums, where we have these places where we have a peak or a valley, potentially. That's what we're looking for anyway. So we found these two locations, two critical points, and those critical points are actually happening where the denominator is equal to 0 and where the numerator is equal to 0. So the numerator is equal to 0 at x equals 0 and x equals 3 halves, which we marked. And then we also had the denominator equal to 0 at 1 and 3. That's where we had vertical asymptotes. We were trying to rush, or at least I should say I was trying to rush, and so I just kind of filled in the chart, and I think I even screwed it up at one point. But I think we got it filled in correctly, where we've got the maximums and minimums of the right locations. So this is where we kind of left off. We had drawn just this much of it, locating the vertical and horizontal asymptotes, and now we're going to try and fill in the rest of it. Okay? So we know that we've got three pieces of the graph that we're going to have to fill in. We're going to have to fill in something to the left-hand side of the first blue line at x equal 1, something in between them, and then something to the right. There's going to be three spots that we're going to have to fill in. And those asymptotes are going to guide us a little bit in how the graph acts at the ends and then at the values of x equal 1 and x equal to 3. But we do need to actually figure out what's happening at those locations. Now, in particular, we found two locations that are very valuable over here. We found a minimum that happens at x equals 0, and we found a maximum happening at x equals 3 halves. Now, we had mentioned when we had looked at these before that that's the x values where I find a minimum and a maximum, but the actual location or the point means I've got an xy ordered pair. So that's where we're going to start right now, is we're going to find that other coordinate so that we can actually plot the maximum and the minimum points that this is referencing. Okay? So we're looking at x equals 0 and at x equals 3 halves. So when we have x equals 0, there we go. What do I get for y? I get a 0 because this particular equation has x squared over x squared minus 4x plus 3. I get a 0 on top. This one gives me an actual 0 for the function. So my ordered pair from this one is actually 0, 0. So I'm going to plot a point at 0, 0, the origin. I plotted it in orange. The other coordinate has an x value of 3 halves. So I need you to grab your calculator or a pencil to work this out if you'd like. We're looking for what the y value is using this equation, x squared over x squared minus 4x plus 3, when x is equal to 3 halves. So if it were me, I would grab a calculator because I don't want to square the 1.5 and so forth. So what do we get? Did you get the values? Snyder, did you get value? No, not yet. -3. Okay, so we have a second ordered pair, which is 3 halves, comma, -3. So on my graph, 3 halves will be occurring between the two. I can't talk today. Between those blue lines, it's between them, right? Okay, good. And it should be occurring at a value of -3. So we've got positive 1.5, -3, so something like this orange dot right here. Okay, that's not what I meant to do. Let's try that again. All right, I think the orange dot's big enough to be seen at this point. Okay. Let's actually take a look then back at that sign chart, because that sign chart that we created is going to be extremely helpful. This sign chart tells us that until I get to the x value of 0, so from the far left until I get to the x value of 0, the graph is doing what? It's decreasing. Is that what you said, Jen? Right, it's decreasing. This piece right here tells me that I've got a negative slope, which means the graph is decreasing from -infinity until I get to 0. Now, think what's happening, and there's no maxes or minimums in between there, right? I mean, there are no places that I have a 0 slope. So it needs to be decreasing until I get to the x value of 0, and then after that, something is going to happen differently. So what in the world would the graph have to look like based on that information? Yeah, it would have to look something like this. It's an asymptote there. I've got to be getting close to that asymptote. Now, technically, could I go above the graph and get close to the asymptote? Yes, but then I'd have another maximum value because I would have to be going above and then getting back down close to the x asymptote, the horizontal asymptote on the far left. So I can't go above because then I end up with another maximum, and I don't have another maximum. So this graph has to look like this. Now, what happens between 0 and 1? It's increasing. So again, from this minimum point that I have at the origin, I've got to be increasing from there on. So the graph must look like this. Does that make sense? Now, sometimes people get a little bit freaked out by the fact that I crossed the asymptote, the orange one that was dotted. There's nothing wrong with crossing that asymptote in the middle of the graph. Remember that asymptote's about end behavior, what's happening on the ends of the graph. On the ends of the graph, it's an asymptote. We just draw it all the way through the graph, but it's the ends of the graph where it actually comes into play. All right, my next location is actually that maximum location that's down there, that orange dot in the bottom, at 3/2. So what happens between 1 and 3/2? It's increasing. So the graph would have to be doing something like this. Right? If read from left to right, the graph is going uphill. And then it stops at the value that's that orange dot, that x equals 3/2 value. And then what happens from 3/2 until I get to 2? Yeah, it says it's decreasing, right? So right now on my sign chart, I'm right into here, this decreasing part here. So over here, and then that also makes sense to us because we know it's supposed to be a maximum. So this sort of looks like this not symmetric parabola. That's what this feels like. It's sort of this crooked parabola looking thing, right? Okay, here's the kicker though over here on the right-hand side. I don't actually have any points to connect, right? Well, let's see what my slope's doing anyway. After x equals 3, what is going on? It's negative. It's decreasing, right? The graph is supposed to be going downhill. So there's really basically two things that I could draw because I can't draw anything with maxes and mins. My graph either has to be doing this and stuck completely below that orange line and to the right of the blue line, or the graph has to be doing this and stuck completely above the orange dotted line and to the right of the blue line. Which one is it? It's this one. Why? This is the only of those two options that's decreasing. Very good. So this is the other piece of the graph, is it looks like this. If you want to be more precise and you want to actually pick an x value like x equals 4 and plot it, that's fine. You could do that. Make sure that you have that detail in there correctly. Since you all have your calculators out, go ahead and graph this. Let's make sure that what you're getting looks roughly like what we've drawn. The equation was x squared over x squared minus 4x plus 3. Does it look right, Allison? Awesome. Did you get it, Cooper? Does it look okay? Yeah? In front? Okay. Did anybody's not look right? Okay, very good. So this is what we were looking for based on the information that we had at our disposal. Okay, we have one last question in this section. This question had to be sketching a graph based on some information. Anytime we have one of these questions, in fact, it always occurs at the end because in your homework sections, they're always the last few or the last question or something like that. These are the ones where there's this sense that I could have a different answer than you do and we could both be right? So that's, again, one of these problems. So sketch a graph of a function with the given properties. F of 0 equals 0. F of 3 is negative 1. Okay, so these two pieces of information have no room for flexibility. They are very specific. On your graph and on my graph, they must look the same. After that, they give us some pieces of information that might not look the same on all of our graphs, at least not exactly the same. The next piece of information is about derivatives, right? So that's somehow different. This one says f prime of x is less than 0 when x is greater than 3. F prime of x is greater than 0 where x is less than 0, and between 0 and 1. And then between 1 and 3, f prime of 0 is 0. I'm sorry. I said that wrong. F prime of x is greater than 0, both less than 0, between 0 and 1, and between 1 and 3. And then f prime of 0 equals 0 at 0. And then the last piece of information again about derivative is f prime of 1 does not exist. And then f prime of 3 is 0. Okay, so let's go through some of these pieces of information because there's a lot of stuff there. The first two pieces of information are the easiest ones to deal with. The ones that I underlined in the black. What in the world does that information tell us? Points. Those are ordered pairs. So if you can get no further, you can at least do that because that's algebra, right? That's stuff you've done for a while now. All right, so f of 0 is 0. That's the origin. And then I've got f of 3 is negative 1. So those are the two first pieces of information. I've got them listed. This is sort of breaking up the graph into some pieces, right? There's something, of course, going on at 0 and to the left of 0. Maybe something between 0 and 3 and something from between 3 and 1. I mean, there's something going on that's different in those pieces of the graph because they're giving us those pieces of information. Let's actually jump and do this a little bit out of order. I want to talk about the does not exist. Let's remind ourselves what it means to have a derivative not exist. There's several things that could happen. What are some of them? An asymptote, that's one. What else could have a derivative not exist? It's been a while since we did this. You could have a jump in the graph, so it's discontinuous. If you could have a jump, you could also have a hole, right? It could just be a gap in the graph. There's one other thing that could happen. Do you know what that's called, Cooper? Sometimes it's called a cusp or a sharp turn. If the graph turns sharply, it doesn't do it smoothly, then you also have a disconnect. It doesn't matter to me which one of these we want to draw. What would you guys like to draw? Asymptote? Asymptotes are easy, so let's do that one. So if there is an asymptote, then that means there's an asymptote happening at 1. So let's actually draw that in. All right, there's my asymptote happening at 1. So I've taken care of that piece of information. What is this f prime of 3 equals 0 telling me? There's a horizontal line. So it could be that I have a max or a min there. Like, that'd be one way to draw it, right? Do I have to draw it so that it has a max or a min? No. That's one of the things that we talked about from the last test that happened, right? It doesn't have to have a max or a min there, but it could. All right, so let's actually look at this in terms of a number line. In fact, I think it might be even easier if I write some of these down as though we were talking about a number line. So let's take a look at the pieces of information that were given that we've sort of skipped at this point. We've got this number line, and what are the numbers on the number line that they are telling us information about, that are breaking this apart? 0, 3, anything else? Something's happening at 1, and in our case, we've decided that it's an asymptote. All right, so this says that the derivative, when it's greater than 3, so that's to the right-hand side of 3, is supposed to be what? Negative. It is negative. So what does it mean for the derivative to be negative over there? The graph's decreasing. Very good. So when we draw this in a minute, we're going to have to draw a decreasing graph on the right-hand side. What else does it tell us? What's happening in all the other places? What's this say? Yeah, on all of the other spots, right? So all of these slopes are positive. So what does it mean is happening at all those locations? It's increasing, right? So it needs to be increasing before 0, increasing between 0 and 1, and increasing from 1 to 3. So what does that tell me is happening at 3? I do, in fact, have a maximum there now, don't I? All right, so in my graph down here below, that's the piece that I can probably fill in the most quickly, is this piece over here like this. I know the left-hand side, I shouldn't have drawn it quite like that, at least not so for sure. I know the right-hand side has to be doing this. I'm sorry, I said right. Left-hand side has to be doing this, because it's supposed to be getting close to the asymptote. because we elected to have an asymptote there, right? That was our choice. The other hand side, it doesn't necessarily have to be doing another half of a parabola, but it does need to be going back downhill, right? So maybe you do, in fact, decide you're going to draw it like this. Maybe you decide you're going to be drawing it like this, where it's sloping very, very gradually, but it does need to be going downhill one way or another. I'm going to leave mine just like this, because it works. All right, so let's actually take a look then at what's happening. I did that between 1 and 3, right? So we need to be doing between negative infinity and 0, and then between 0 and 1. So what am I going to do between negative infinity and 0? So on the far left-hand side of the graph. It's going up somehow, right? But what has to actually happen at 0? What's that piece say? I know I highlighted just yellow on top of yellow. That was not my best choice, but what does it say has to be happening there? Yeah, the slope needs to be 0 there, right? So what does that mean in terms of the graph? It could be a max, it could be a min. Can it be a max or a min on this graph? No. How do you know? Because it has to be increasing on both sides. So it's not a max, it's not a min, but I still have to do something that I actually get a 0 there. So what's it going to have to look like? Somehow it flattens out right there, right? So potentially something like this could be happening. Like the x cubed curve, y equals x cubed. Except that it's not, because it's trapped by that asymptote weird thing going on. The other thing you could do is you could say that it is, in fact, something like y equals x cubed. And it actually stops. I mean, we could have an asymptote and a hole in a graph. We could do that. It's our choice, right? If you don't want the asymptote there, at this point, if I put a hole in the graph right there, I could just take out my asymptote. It would still satisfy the conditions, right? But the details have to be there. I have to have those blue points. I have to have that max in the right place. I have to have the slopes doing the appropriate things. But it wouldn't necessarily have to look like this. Any questions on this one? All right.